Have you ever wondered about the origins of the humble calculator? Let's travel back in time to the late 16th century when a brilliant mathematician named John Napier was changing the game. Hailing from the beautiful land of Scotland, Napier was a polymath who wore many hats. He was an astronomer, a physicist, and a Neoplatonic philosopher. But the crown jewel of his achievements lies in the field of mathematics. And it's here that we encounter Napier's revolutionary invention, a set of rods or bones as they were often called, that would forever transform the world of calculations. These Napier's bones, as we know them today, were a groundbreaking invention that made complex multiplication and division a breeze. They served as a precursor to the mechanical calculators we'd see centuries later. This is the story of a man who changed the face of mathematics forever. Now you may be wondering, what exactly are Napier's bones? Well, it's time to delve into the fascinating world of 17th century mathematics. Napier's bones, named after their inventor John Napier, were a groundbreaking tool that simplified complex calculations. So how did they work? Picture a collection of rods, each 10 squares high and marked with the digits 0 to 9. Now imagine these rods are arranged side by side, creating a sort of grid. This is the basic setup of Napier's bones. The magic happens when you use these rods to perform multiplication. Let's say you want to multiply 7 by 8. You would align the 7 rod and the 8 rod next to each other. Then you'd look diagonally across the two rods. The numbers you'd intersect would give you the answer 56. It's as simple as that. But what about larger numbers? The beauty of Napier's bones lies in its ability to handle these with ease. Suppose you want to multiply 23 by 45. Again, you'd arrange the rods to represent these numbers. 2 and 3 for 23 and 4 and 5 for 45. You'd then perform the multiplication process for each pair of rods individually and sum the results to get the answer. And division? Well, it's just the reverse process of multiplication. If you want to divide 56 by 8, you'd look for the number 8 on the rod and follow it to the number that would give you 56 when multiplied by 8. In this case, it would be 7. The brilliance of Napier's bones lies in the fact that they turned multiplication and division, operations that can be tedious and error-prone when done manually, into a simple process of aligning rods and reading off the result. They were an invaluable tool for mathematicians, accountants, and anyone else who needed to perform complex calculations quickly and accurately. In essence, Napier's bones were the calculators of the 17th century. They paved the way for the mechanical calculators and computers we rely on today, and their influence can still be seen in the world of mathematics. But why were Napier's bones so revolutionary? Well, let's dive into that. In the age of paper and pen, calculations, especially complex ones, were a tedious chore. Enter Napier's bones. This ingenious device, invented by John Napier in the 17th century, simplified complex calculations, making them faster and more accurate. It was a tool designed to aid in multiplication, division, and even square roots, without the need for extensive memorization or complex written calculations. The beauty of Napier's bones lies in its simplicity. Each bone or rod was marked with a series of numbers that corresponded to a multiplication table. By aligning these rods in a particular manner, complex calculations could be performed easily. This was a boon for mathematicians, scientists, and anyone else who frequently worked with numbers. Napier's bones played a crucial role in the development of mathematics. They were a stepping stone towards more advanced calculating machines, and ultimately, the computers we use today. They laid the groundwork for the concept of logarithms, another of Napier's notable contributions to mathematics, which are fundamental to many areas of math and science. These humble rods were more than just a calculating tool. They symbolized the human endeavor to simplify and conquer complexity. They showed us that with clever thinking and innovation, even the most daunting mathematical challenges could be tamed. Napier's bones were a game changer in the world of mathematics. They sparked a revolution, transforming how we approached and solved mathematical problems, forever leaving their mark on the annals of mathematical history. Opening. How did Napier's bones compare to other mathematical tools of the time? Imagine the world of mathematics in the 17th century. Two tools stood out as revolutionary: Napier's bones and the slide rule. Both shared the same mission to simplify complex calculations, but they approached this mission in different ways. Napier's bones, as we've discussed, was a set of numbered rods that made multiplication and division a breeze. They were portable, easy to use, and versatile, capable of handling a wide range of calculations. The user simply arranged the rods in a specific order, and voila, there was your answer. On the other hand, the slide rule, invented nearly a century after Napier's bones, used logarithmic scales to perform multiplication and division. It was a ruler-like device, and the user slid one part against another to find the solution. The slide rule was faster for some calculations, but it was less intuitive and had a steeper learning curve. Both tools were ingenious in their own right. Napier's bones brought multiplication and division within everyone's reach, while the slide rule gave scientists and engineers a fast, efficient tool for complex computations. However, Napier's bones had an edge in terms of versatility. They could handle more types of calculations and were easier to use for the average person. Closing, while both had their uses, Napier's bones were uniquely versatile. How have Napier's bones fared in our digital age? As we journey through the corridors of time, we see that the advent of electronic calculators and software have largely replaced the use of Napier's bones. The digital revolution has brought about a wave of change, equipping us with increasingly powerful tools for mathematical computations. Devices small enough to fit in our pockets now perform calculations at speeds that would have seemed impossible in Napier's time. Yet, despite this digital shift, Napier's bones have not been entirely forgotten. They continue to hold their ground in the world of mathematics education, serving as a fascinating tool to introduce students to the principles of multiplication and division. They offer a tactile, hands-on approach to learning, helping to demystify these fundamental operations. Moreover, in the realm of software development, Napier's bones have found a new lease on life. Certain educational applications and games have integrated the concept of Napier's bones into their design, allowing users to explore and understand the principles behind this ingenious invention from the comfort of their digital devices. It's also worth noting that the principles behind Napier's bones have influenced the development of modern computational algorithms. After all, at their core, these bones were an early form of algorithmic thinking. So, as we see, even in the kaleidoscope of the digital age, Napier's bones continue to find relevance, offering a testament to the enduring power of innovative thinking. Even in the age of digital calculators, Napier's bones hold a special place. But Napier's bones weren't John Napier's only contribution to mathematics. Indeed, this Scottish mathematician's brilliance extended well beyond. One of his other notable inventions was the concept of the decimal point, an idea that revolutionized the way calculations were performed. Imagine trying to multiply or divide large numbers without it. Napier also made significant strides in the field of physics. He invented a two-mirror device known as Napier's burning mirror. The contraption was said to set ships on fire by focusing sunlight onto them, though it's more likely that it was used for more peaceful purposes, like signaling or heating. In addition, Napier's work on logarithms cannot be overlooked. His publication Mirifici Logarithmarum Canonis Descriptio introduced the concept of logarithms to the world, simplifying complex calculations immeasurably. He even dabbled in astronomy, devising a method to calculate the motion of planets. John Napier was a true pioneer in his field. The world of mathematics and science is certainly richer for his contributions. So, what is the lasting impact of Napier's bones? Let's delve into this fascinating journey. The legacy of Napier's bones is deeply ingrained in the annals of mathematics and technology. These ingenious instruments were more than just a set of numbered rods. They were the precursors of the modern calculator, paving the way for a revolution in computational methods. John Napier's invention was the catalyst that simplified complex calculations, making them accessible to a wider audience. This democratization of computation was a significant stride forward, shaping the course of mathematical advancement and technological innovation. Fast forward to today, and we find that Napier's bones have not been left in the dust of history. Their designs and principles are preserved and exhibited in museums around the globe, serving as a testament to Napier's genius. These historical artifacts continue to inspire and educate, reminding us of our mathematical heritage and the strides we've made since. Moreover, Napier's bones are still utilized in educational settings, providing a tangible, hands-on approach to understanding multiplication and division. They serve as a bridge, connecting the past and the present and reminding us of the enduring power of innovation. So whether you're marveling at their ingenious design in a museum or manipulating a set in a mathematics class, the influence of Napier's bones is undeniable. They remind us that innovation is not just about creating something new, but about improving and simplifying the way we do things. From the 17th century to the present day, the legacy of Napier's bones lives on.